Hey, ladies and gentlemen, it's your well-rounded math teacher again, Mr. Picard here. And we're going to get into Intro to Logarithms here, 8.2. But the first thing I want to do is kind of review what we did last week. Actually, not last week, 2 days ago. Working with solving these exponential equations. And that means you have to get the base to be the same. Well, I have a base of 4 and I have a base of 2. So I can get 4 down to a base of 2. I just got to break that down. 4 is 2 times 2. So that is 2 squared. And I have to put it in parentheses because that 4 was to the 3x power. So 2 squared is to the 3x power equals 2 to the 3x plus 1. Getting rid of those parentheses now so we can set the exponents equal. We multiply right here. 2 times 3x is going to give me 2 to the 6x equals 2 to the 3x plus 1. Since I have the same base now we can say, well, 6x equals 3x plus 1. I'm just going to subtract 3x from both sides. Let's write it again over here. If I subtract 3x from both sides, I'm going to get 3x equals 1, and then just divide both sides by 3. So x equals 1/3 in this case, okay? So once again, you got to get it down to the same base. Here, 81 and 27, hey, we could do a base of 9. Like 81 is 9 times 9. I think this will work. And 27 is 9 times 3. Ooh, this is not going to work because I need 27 to be a power of 9. Well, it's 9 times 3. That's not going to work. But we can do a base of 3. 27 is 3 to the 3rd. So 3 to the 3rd raised to this x minus 2 power here equals 81 is going to be, well, this is 3 times 3 for this 9 and 3 times 3. So the 9s are gone now. It's 3 to the 4th power. So 81 is 3 to the 4th power, and that's raised to the x power. So I got to put it in parentheses again. So before I can set these exponents equal, we got to get the bases the same. Well, they are both 3, but they're in parentheses. So I got to multiply here. So this is 3 to the 4x. 4 times x is 4x equals 3 to the, here I would get 3x. A lot of people put minus 2 here, but don't forget 3 times negative 2. That's going to give me 3x minus 6. Now I have the same base, so 4x equals 3x minus 6. And we're just going to subtract 3x from both sides and end up with x equals negative 6. And there we go. That's kind of what we did with section 8.1. Now on to 8.2. Intro to logarithms. We got to be able to go from exponential form. Now, there's no variable in the exponent here, but this was what we consider an exponential equation because it's 2 to the 5th power. That's my exponent, I guess. And so I'm going to say that's my exponent. And 2 is my base. Those are the two main things to setting up your logarithmic equation. When you write logarithmic equations, so to go over the other side here, you're going to say log base. Well, my base is 2, so you're going to kind of do a little subscript here. So like an exponent is up, a base would be down when you write it for this subscript. Of 32 equals, it's always equal to the exponent, which is 5. So there's my exponent, and there's my base. Those are the two things you got to find. Log base 2 of 32 equals 5. That's how you would say that. So if I had b is my base, to the x exponent equals y, how would I write this as a logarithm? It's going to be this, log base b of y equals, it always, when you're writing logarithms, it's always equal to the exponent. Well, the exponent over here was x, so that's what it would look like. So one thing is just kind of writing these logarithms. And a lot of people struggle with, well, why do we got to learn logarithms? It's another way to solve these exponential equations, which is a little bit easier, and you're going to see that in a minute. So here we go. 6 is my base. And 3 is my exponent, okay? So this is going to become log base 6, do a little subscript 6 of 216 equals your exponent, which is 3. So going backwards, here's my base 4, okay? Going back to an exponential form equation. Find your base, find your exponent, and there you go. This is 4 to the 5th equals the number part of it, which is 1024. So 5 is my base, x is my exponent. See if you can write a logarithmic equation. Hit pause and try a couple of these. If you make a mistake, well, that's fine, you'll learn. If you hit pause, go ahead and hit pause and try them. I'm going to try them now for you. This is log base 5 of the number part, which is 625, always equals your exponent when you're writing logarithmic equations. So equals x. Going backwards, my base is 3 right there, log base 3, and my exponent is the x right there. It's equal to your exponent when it's written as a logarithm. Now this equals the number portion of it, 2187. Base 10, exponent 2. So 10, whoops. Let's go blue. 10 squared equals x. And you guys could probably do this one. What's 10 squared? Well, it's 100, so x equals 100 in this case. Some of these are kind of easy to solve as exponents. A lot of them are easier to solve as logarithmic equations. My base is 2. My exponent is 8x. So it's going to be log base 2 of the number part, 65,536, equals your exponent, which is 8x. And there you go. Okay, so solving these logarithms. This is an exponential equation. I could keep plugging numbers in for x until I get to 4,096. That's one way to do it, but sometimes it's a decimal. So we're going to use logarithmic equations. So we're going to change this to a logarithmic equation. It's going to be log, my base is 2 of 4,096 equals the exponent, which is x. Okay, I got my log base 2 of 4,096. You can plug that into your logarithm now. Here's how it works. You have to hit the function button, and there's distinctions, statistics, trig, distance formula, whatever. Miscellaneous is what you want. And in the middle column, if you go down floor, percent, nth root, there's log base A. You want to hit that log base A button because we want to type in our base, which is 2. So I'm going to hit 2 here. You can tap on the parentheses or just hit that arrow key to the right a couple times and type in 4,096. And there it is. X equals 12. That's my answer. It's that simple. They get a little more complex, but not too complex. Your exponent is x minus 1 now. Keep that in mind. My base is 2, so I'm going to write my log base 2 of 80 equals x minus 1. We'll come back to the x minus 1 in a minute. Hit function, hit miscellaneous, and then go down. It's in the middle column. It's up from the bottom one, that log base A. There it is. I can type in 2 again. You can touch on the parentheses, or you can arrow over a couple times to the right. Type in 80. And now you get a decimal. So you couldn't have figured this out by just plugging numbers in for x. This is 6.3219. We usually go 4 decimal places, 1, 2, 3, 4 when we're working with logs. But if you even put 6.32 or 6.3, that would be fine. So here's your equation now that you got to solve. Well, it usually is just x, but now I got x minus 1. So I'm going to add 1 to both sides. It's that simple. So I got 7.3219 equals x. And that's it. That's logarithms. There should be a button on your graphing calculator if you got one. But yeah, you can just use Desmos to plug in these logs. Let's see what we got here. Well, now you got your homework. So you can go from exponential form to logarithmic form and logarithmic form to exponential form. I think I could maybe we'll do 7. That looks like a tougher one. 9 and 8 are just like 7. It's just a little bit bigger numbers. So let's do 7, and then I'll let you guys kind of work on your own. So this is an exponential equation. We have a variable in the exponent. We want to write it as a logarithmic equation. Your base is 4. And your exponent is 2x minus 1. So just remember, when it's in a logarithmic equation, it's always equal to the exponent. So log base 4 of 88 equals 2x minus 1. Okay? So find that. What is log base 4 of 88? So hit the function button, hit the miscellaneous button, and go down to that middle column, second from the bottom there, log base A. Type in 4 for your base. You can arrow over, just touch the parentheses and type in 88. And that's going to give you, what is it, 3.229. 7 equals 2x minus 1. So now it's just a matter of, you don't have a logarithmic equation. You just got to solve this. I'm going to add 1 to both sides. And I'm going to get this. 1 plus 3.2297 is 4.2297 equals 2x. Then just divide by 2. Oh boy. Let's get another one here. 4.2297 divided by 2. And it's that simple. X equals 2.114. We'll say 9. We'll just round it. Even if you put 2.11, that would be fine. There's your answer. And we're good to go. If you have any questions on this, shoot me a message and we can work on it. Maybe do a Google Meet or something. Sign up for some office hours. Have a great day.